Good afternoon or good evening, depending on where in the world you may be listening. Welcome to today's Dark Reading webinar, Protecting Industrial Control Systems from Modern Threats, sponsored by Xona and broadcast by Informa. Terry Sweeney here with Dark Reading. I'll be your moderator today. Just a few quick announcements before we begin. This webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, and share this webinar on social media. This is also where you'll participate in the Q&A session that takes place at the end of our presentation. The slides advance automatically throughout the event. You can also download a copy of the slides using the resources widget. Toward the end of our webinar, we'll be asking you to provide feedback using the survey widget found at the bottom of the screen. Please take a minute to fill this out before you leave us today, as your feedback provides valuable information on how we can improve future events. Lastly, if you're experiencing any technical problems, please click the Help widget found at the bottom of the screen. You can also type your issue into the Q&A area, and we'll be glad to offer one-on-one assistance. Now on to the presentation, Protecting Industrial Control Systems from Modern Threats. Discussing today's topic is Dr. Jason Clark, an independent security researcher with nearly 20 years of real-world experience within the intelligence community, academia, and industry. Jason brings extensive knowledge and experience on a variety of technology-related topics. Currently, his main area of interest is researching and analyzing better methods to detect, deter, and mitigate insider threats. When Jason's finished, we'll hear from Bill Moore, CEO and founder of Xona, which provides unique zero-trust user access control and analytics platform for critical infrastructure. Currently focused on helping global power, oil and gas, and manufacturing customers reduce their remote operations costs and cyber risks, Bill has more than 20 years of experience in security and the high-tech industries, including positions in sales, marketing, engineering, and operations. Jason Clark, over to you.
All right, hello everyone. I appreciate you spending an hour of your day to participate in this webinar. My name is Dr. Jason Clark, and I'll be presenting from just outside of Raleigh, North Carolina this afternoon. I want to thank Dark Reading, the sponsor Xona, and all of you in the audience for the opportunity to present on today's topic, Protecting Industrial Control Systems from Modern Threats. So on this slide, I just kind of wanted to provide two clear definitions of terms that I will frequently use during this webinar. The first is Industrial Control Systems, shorthand ICS. This definition that I have on this slide is courtesy of NIST, and it kind of defines ICS as an information system used to control industrial processes such as manufacturing, producing, handling, production, and distribution. Next is operational technology, shorthand OT. So OT here is defined as programmable systems or devices that interact with the physical environment. So these systems or devices detect or cause direct change via monitoring of controls of devices, processes, and events. So just want to kind of get us on the same sheet of music. Sometimes terms can be a little bit challenging and stuff like that. So I just wanted to kind of get us off on the right foot because I'll be using these terms, and especially to save time, ICS and OT, I'll be using those terms a lot. So just wanted to kind of on this slide just show where you might find these industrial control systems and operational technologies as they were just defined. They're found in all types of sectors, energy, of course, oil and gas, which is an energy, manufacturing, government, and you might see them applied to areas such as like wind farms, solar arrays, gas power generators, smart grids, labs, in water treatment plants. They can also be found in like food processing plants, all types of manufacturing, and the list really goes on and on. But at least this slide, I think, should get us in the right frame of mind. So, kind of before I really started begin, my remarks and stuff I really wanted to cover, I just wanted to highlight some ICS and OT trends. These were captured during a recent SANS 2021 survey. I found them kind of interesting and thought I would present them on one slide. In the survey, SANS, they found that there was a steady increase across a number of metrics, including like hiring of ICS-focused cybersecurity positions, increased budget allocations of ICS cybersecurity. This is really great news as far as I'm concerned, because enterprises are seeing the need and the value of getting their ICS and OT systems and environments secured with bright minds and innovative tools. There's also been an influence in regulatory regimes, even like cloud adoption, leveraging things such as the MITRE ATT&CK framework. We'll touch a little bit on each of these in more detail as we progress through the slides. But I just want to kind of see, this idea of going to, I guess these trends of increasing ICS and OT trends. We're seeing a steady increase in a lot of the things that I'll be covering today. So I just wanted to highlight that. Okay, so in this slide, this is kind of a challenge, but I wanted to try to convey the plethora of different ICS and OT industry concerns that I've come across in my own experiences, both professionally and academically in this space. And so, you can sort of see the reasons why ICS and OT practitioners, owners of the plants, and so on and so forth, are up at night. They're quite plentiful. Of course, they're associated with security. There's other ones on here, such as like reliability and safety, protection of external people and property, outdated policies and procedures, things like financial loss, inability to protect trade secrets, and compliance. So there might be some others that I'm missing. So throw those in the chat if you want. But I just think it's good to kind of see, what are some of the concerns as it relates to ICS and OT. So I tried to capture some of them because, to me, security is the main focus for this webinar, but there's other concerns out there that I've highlighted in this slide. So as promised, wanted to kind of talk a little bit about the security challenges. It's pretty much correlated, if you will, to the previous slide that addressed the concerns. But here I wanted to look a little bit more at security, since that's why I'm sure many of you came to this webinar. So for example, like cybersecurity risks, they could be linked to challenges associated with this integration of legacy OT with sort of modern systems. In my opinion, a lot of the enterprises out there, a lot of the ICS labs, plants, they're not really prepared for sort of the modern attacks. And there's a dilemma between security versus usability, of course, and it's one that's difficult for any organization, especially ICS and OT, to handle. So there's quite a few reasons for this, but I think it really drives at the fact that we have these modern IT sort of on these legacy systems. So that's kind of a central theme that I want you to all keep in mind during the rest of the webinar. So I don't want to spend too much time on this slide. Presumably many of you, know the types of attacks out there. But ICS, both the big ones and the small ones out there are, of course, potential victims of cyber attacks. There's a lot of various threat actors out there that have this sort of the means, the opportunity, and the motivation to attack industrial control systems. These might include hackers, organized crime, current or former contractors and equipment providers. That's kind of the insider threat nexus. There's also things like hacktivists and activists, foreign nation states, and associated intelligence services. The two main attack vectors are malware, kind of generally speaking, and then ransomware. So additionally, these threat actors are targeting also devices and Internet of Things that really don't have the ability to protect themselves too well. There's other issues like unintentional or accidental kind of mistakes, compromised applications, and of course the adversary's classic favorite, the phishing attacks. So next up, I wanted to look at one specific use case, and of course, this is the one that was highlighted in the webinar description. So as promised, front and center now is the use case discussion on the Oldsmar water treatment plant. So, hopefully the slides are, you can easily view them. But the story kind of begins on the morning of February 5th, 2021 in Oldsmar, Florida, which actually, for the sports fan out there, was about 15 miles from the location of the Super Bowl that year. The first interesting event was the technician on site. He noticed the cursor on his screen was like moving outside of his control. Initially, this was not very surprising though. At this water plant in Oldsmar, they used TeamViewer, which is an application often used by like help desk analysts to remotely administrate or kind of take over an employee's screen to sort of render them assistance in troubleshooting of some sort of IT technical problem. So at this particular water plant, though, this is typical activity that was performed by the site lead and the management structure in there to connect to computers to sort of better monitor facilities and systems. So, that wasn't too surprising at the time. But then, fast forward a few hours later, and of course, the mouse began moving, wildly around the screen for a second time. And this time, the technician on site was convinced that he was witnessing a cyber attack unfolding before his very eyes. So as the attack was underway, the adversary began clicking through water treatment plant controls. The attacker briefly adjusted levels of sodium hydroxide to dangerous levels. So I'm not a chemist or anything, but during my research, I learned that the attacker was intentionally moving the setting from 100 parts per million to 11,100 parts per million. And so, of course, this amount is extremely dangerous to human skin should it make contact. So as the story kind of draws near an end, there's a few lessons learned. First, the employee was quick to spot the intrusion. Whether this was a bit lucky or skillful kind of remains to be seen. As such, the technician was able to return the sodium hydroxide back to normal levels. For the curious reader out there, the poisoned water actually was still about 30 hours away from reaching the population. And there was also additional checkpoints and safeguards, such as additional pH testing that were in place. So in my mind, this also shows the fact that it's really important to avoid single points of failure, both on the employee and the device side of things. And we'll explore this case a little bit more in the slides to follow. We'll start looking at some best practices and lessons learned that we can glean from this particular use case. So buy one, get one free use cases for your enjoyment. So I just wanted to add another one that I think is really interesting that I'm sure many of you have heard about. So this is Colonial Pipeline. They transport about roughly 2.5 million barrels of fuel daily from the Gulf Coast to the eastern seaboard, I guess. It's quite a lot of fuel. So on April 29th, 2021, hackers gained entry into the Colonial Pipeline network through a virtual private network account. The account was no longer in use, but was still somehow leveraged by the attackers. As it was later determined, the password associated with the account was found in a data leak that was shared on the dark web. So then using these credentials, the attacker could just simply authenticate via username and password. So it's trivial for them in large part because there was no multi-factor authentication in place. One thing. One point I forgot to mention is that it was unclear how the adversary actually found the username, as no phishing evidence was actually found. But anyway, more than a week later, on May 7th, a ransomware note was found by one of the technicians on site. And therefore, the technician immediately informed the supervisor, who began shutting down the pipeline for the first time in its over 57-year history. So in terms of follow-up, the security firm Mandiant actually helped support the security assessment and then lead the forensic evidence gathering effort. And then interestingly, at least to me, Colonial Pipeline actually ended up paying the $4.4 million ransomware. That could be a discussion for another day. But and then as a result of this, Colonial Pipeline did hire additional security firms to sort of help solidify their security posture. So hopefully this doesn't happen to them again. So just to be clear, I did want to say that as far as I know, as far as most people know, these attacks are kind of unrelated. But for our purposes, I think combining them, because I think they do result in many similar takeaways that can be used to derive lessons learned and best practices. So as you think about the previous use cases with the water plant and Colonial Pipeline, put yourself for a second in the shoes of leadership. So what are some of the key questions or issues that would need attention? For me, it really begins with gaining a better understanding of who is entering your system and why. So ask yourself the question of, do you think you know who is accessing the system versus do you actually, without a shadow of a doubt, know? This question and sort of ones like it, I are what I think needs to be addressed first and foremost. Next, you can talk a little bit about the weaknesses and the holes as it relates to an adversary gaining access. So in the use cases, we identified TeamViewer and VPN as sort of the weak links. And they're certainly part of the problem, as are the ports and protocols that they use. Pretty clear that those can be compromised. However, in my opinion, just fixing kind of each application does not really truly get to the root of the problem. So instead, we want to think about how to break the kill chain and how we can better, efficiently, and generally reduce the attack surface. So to address these questions, I think we need to take a long, hard look at authentication. So the authentication used for Colonial Pipeline was simple username and password pair. Instead, maybe think about enhancing authentication with something like multi-factor authentication, which of course would make it more challenging for the would-be adversary. It's also crucial to ensure that authentication and authorization is based, on this most secure way possible. So, again, if you're going to use MFA, there's quite a lot of different opportunities to use things like RSA tokens, these hard tokens, YubiKeys. Those are very popular. You can use things like identity certificates or OTP, one-time passwords. Those are good candidates. Which should be explored based on the requirements of your individual organizations. So another idea is kind of getting a handle on ports and protocols. In my opinion, you really want most of these locked down and secured. So when you have to do things like patching, there should be kind of a more sophisticated way to get the file from system A to system B. Sort of temporarily opening it up or coming up with some new mechanisms and techniques to accomplish this without sort of opening up the proverbial front door. Also of interest, I think, is having a live user connection monitoring and session recording tool in place. This could be used to sort of replicate the attack. It can also be used for key forensic evidence should it be necessary, maybe when you're trying to recreate the attack or maybe for some sort of investigation. So in light of the use cases and the takeaways we just discussed, kind of ask yourself, what are some of the technical and operational goals for ICS and OT? So from a technical perspective, I think one of the things should be considering, besides the authentication, is again reducing that attack surface. So you might want to consider things like implementing a virtual waiting room. This essentially means that a user or a technician, something like that, needs to be let in, approved or confirmed to access the system, device, or portion of the network. One of the major initiatives that I'm seeing across the board is zero trust. We'll explore this in a lot more detail shortly. Other ideas that come to my mind are things like protocol and asset isolation. Again, better stated, maybe how you can make a port, perhaps temporarily, or protocol while it's locked down, but still able to utilize it. So I guess instead of making all of your assets, reachable and open with full access, you should be more restrictive and kind of smart in terms of what you allow. There's a lot of solutions that do this sort of thing that essentially allow the enterprise to create customized policies for access control based on things like user, device, time, and other criteria. Forensic and investigation capabilities are imperative, of course, for success in this area. And again, we'll look at those in a few more minutes. Changing gears slightly, there's certain operational goals the ICA and OT community should consider. This again begins by reducing the operational costs while also keeping security tight. In order to achieve this, I think simplifying deployment by reducing complexity is critical for success. Tool implementation and selection is also a key factor. So this goes hand in hand with the next bullet of compliance requirements. So if you sort of select one tool, you need to ensure that it is not adding risk to the organization or otherwise undoing compliance requirements that another tool has in place. So what I'm driving at is creating a scenario whereby multiple tools are interfering and conflicting with each other, which is bound to happen in this hybrid, modern and legacy kind of combination environment. And then digital transformation, all about allowing cyber teams and IT teams across the OT and ICS estates bringing these kind of disparate teams and systems together while trying to be mindful of each other's risks. There's this constant battle between the legacy and OT teams, the legacy OT teams and sort of the modern IT teams. A lot of acronyms here. So, for example, the IT team might say, hey, we need to add this cloud connector. We need to install Active Directory, and the OT teams are like, I don't think so. Well, IT saying this is coming from management as a new initiative, so there needs to be this good, clear communication channels, making sure that we're not adding undue risk, but still keeping the power plant or nuclear plant, what have you, keeping it running. So how do we accomplish some of these goals? That's kind of the question. So again, reducing the attack surface, one of the more important areas to focus on. This could be kind of general and go in many different directions. However, to me, again, it's all about reducing risk and not introducing any more of it into your environment. This can be accomplished, as I said before, not allowing unnecessary technologies. Active Directory or cloud connections are two classic ones that I've seen. Of course, you might need those for your environment, but don't add it. If it's going to cause undue stress and cause risk. You also want to limit exposures to devices and machines on the network. The waiting room idea is one approach that I said before. Also, like eliminating unused devices and machines. One of the common misnomers I hear a lot is, you need 25 firewalls in place. So, implementing minor firewalls around the isolated control system, industrial control systems won't actually work all that well. Again, this doesn't really get at the heart of the problem we're trying to solve. So instead, maybe consider removing and replacing those drives and machines that are not really adding any value, but instead they're just increasing the attack surface. There's a lot of best practices around things like configuration management that I also subscribe to, timely patch management, creating options for secure file transfer, protocol isolation, are all ways, again, that you can ensure that systems are updated, patched, and all the holes are plugged. So as promised, I wanted to talk about, go back to Zero Trust. For those that don't know, I think everyone maybe does, but just for everyone's awareness, Zero Trust ensures organizations kind of verify all people and devices that attempt to join the network. This is based on the trust nobody mentality. The idea is that Zero Trust is afforded to any particular user, device, system. So instead, like each individual component, each individual component will be built with security in mind. So what I'm trying to say is the objectives are to move away from outdated security design. So like when mentioning outdated security design, you also often hear about that like castle and moat analogy. So we want to move away from a design where all that is protecting the ICS and OT environment is like a moat. To accomplish this, continuous monitoring and verification of each asset must be done. So again, the key takeaways here, that Zero Trust is that it needs to be built, in my opinion, from the inside out. So this will require enterprises to define mission outcomes and requirements via policy and procedures that are tested and then understood by all the stakeholders. So the ability to quickly adapt and configure policies and procedures should be explored. For Zero Trust to be effective, there needs to be a focus on protecting critical assets and then specifically determining who or what needs access to a particular asset and why. So it's suggested, at least in my opinion, that you all make Zero Trust like a specific selection criteria when you're assessing a new vendor, tool, or technology. So the question kind of begs, how do we get to Zero Trust? What is the path forward, especially in a ICS and OT environment? And, like, how do you adopt Zero Trust? Of course, this could be a webinar in of itself, but for our purposes, again, Zero Trust, it really makes it more difficult for the adversary to gain unauthorized access. But this is something that you just can't, hit a switch and just do this overnight. Implementation takes a lot of time and resources. One of my recommendations that you incorporate one component, one piece of the network, one asset, if you will, at a time, and do that in sort of a safe, secure, controlled manner. I have young children, and it reminds me of this classic children's joke. I was recently told by my daughter, how do you eat an elephant? Well, one bite at a time. And I think that's true for zero trust. You can't do it all in one night, like I said. So, piece by piece, component by component, making sure it's tested thoroughly so you're not increasing any undue risk. And, you want to make sure that you have the benefits of zero trust and not actually, by way of implementing zero trust, you actually cause some other, major conflict, is what I'm driving at here. Another key ingredient in protecting ICS and OT from modern threat is protocol and asset isolation. Briefly touched upon this earlier and kind of returning to it now. The idea here is you want to isolate the critical devices from general network traffic. This kind of makes it more difficult for the adversary to unleash their attacks. So depending on each individual use case, there should be some semblance probably of network connectivity between devices and trusted entities. However, most of the time the network connectivity doesn't have to be there like 24/7, 365 unless there's a particular situation for it. So what I'm trying to say is the bottom line is we need to ensure that protocols are available when they're needed, but otherwise having them secured and closed is the recipe that I would subscribe to. We should also limit code and software updates to these critical assets. By using protocol isolation and that on the assets as well, we can turn things on when a major update is required. There's definitely amazing technology out there that can convert remote protocols into encrypted displays, and all of this can help reduce the attack surface dramatically. Next up, I wanted to let me change the slides. Next up, I wanted to talk a little bit about the importance of allowing technology to help with forensic investigation and auditing. And of course, there's a myriad of reasons why this should be important. For example, compliance, monitoring and detection of potential insider threat, trying to maybe see if you can determine intent, unintentional versus a malicious attack. There's other things around like proof of origin, investigations and evidence gathering, and really the list goes on and on. So to help put this in place, I think it's recommended that detailed logging of all events, actions, and changes are enabled. It's best if there's multiple sources for evidential gathering set up across the environment. Incorporating and utilizing technology to capture and save video, screen recordings is paramount for success. Having multiple sources for forensic investigations and auditing can only really help you. You want to make sure that the ideas of non-repudiation and proof of origin, which are the cornerstones for an effective forensic investigation and audit, are in place. So reducing complexity. So one recommendation that you can start immediately is to sort of ponder in your mind how you might reduce complexity in your environment. So to the extent possible, I would say you want to avoid difficult implementations, reduce the number of components that are added. Often technology can be used for dual purposes, and sort of a modern and streamlined technology might help replace existing technology. This is a tough one, but seemingly everyone's kind of going to the cloud. This might not be the best approach for an ICS OT environment, although it actually is one of the trends that was identified by SANS. So, I think really it's up to you. You have to do your homework is, I think, what I would say. You might not need to be striving to go to the cloud. Instead, maybe trying to restrict your cloud exposure is the recommendation here, at least from my opinion. Also, things for sure, reduce latency, and then essentially strive for normalization and consistency. So as I come to the end of my time here, I do think this is quite the timely discussion because the threats to ICS and OT are not really going away. They're becoming more sophisticated. The attacks, that is, are becoming more sophisticated. They're coming from all types of threat actors and vectors. Again, I told you, remember that theme. ICS and OT, they were not really built with a security focus. Although I do firmly believe that technology solutions are available today that can really help legacy ICS and OT environments kind of mesh with modern IT. So in this slide here, I captured many of the goals objectives that I covered in this portion of the webinar. I think reducing complexity and in turn shrinking the attack surface are the most advantageous things in ICS and OT infrastructure practitioner can do. So again, by merging disparate systems without adding unnecessary risk, streamlining processes, and then securely moving files and patches in a closed system is a really great start. This can be improved further by infusing zero trust, adding a strong forensic investigation auditing capability, and maybe most importantly, understanding who has access to your critical components and why. This will allow you to be well on your way to protecting your industrial control systems from modern threats. Just want to say one last point. In the slides that are downloadable from Dark Reading in a few days, you'll be able to see some of the list of references that I used if you wanted to go on your own kind of journey. I want to also say I truly appreciate everyone's time, attentiveness, and participation. I very much look forward to the upcoming presentation and the Q&A to follow. Thank you so much, and I'll now turn it over to the CEO and founder, Mr. Bill Moore from Xona. Thank you so much.
Thank you, Jason, and also thank you to Dark Reading. Really appreciate you putting this on and for everybody joining. So when we talk about digital transformation, we kind of touched on that with Jason, but wanted to talk a little bit about, there's obviously a huge movement going on with industrial Internet of Things and these previously air-gapped assets coming online. So, and there's a number of reasons for that, to get more data, to understand, health of the network for safety reasons, but also, there is things with cybersecurity that's kind of a double-edged sword there when bringing them on. So there has to be an approach to kind of understand how to secure access to the devices and the industrial control systems and operational technology around that. And really, this is all about, from the business perspective, of unlocking business value by being able to gather the data analytics from all of these distributed networks, right? So what's kind of driving this from an IIoT standpoint and sort of legacy assets is being able to access this remotely. There's a number of things with obviously the pandemic is driven the need not just for corporate IT, but also it's also driven a need for operations to be able to access these systems in a much more secure way than they have previously. There's a lot of complexity here that's driving this approach in terms of, dependent on enterprise IT legacy tools that are not really built for OT. Then you have the OEMs and other third-party contractors that need to have access, and how do you bring them online without over subscribing permissions and so forth. And then, being able to figure out, an inexpensive way of doing this and, really not, enabling really the OT folks, the control systems managers, automation engineers, plant managers, to be able to, acquire new technology, make it more frictionless, and be able to maintain it as well without a lot of IT administrative overhead, right? So we touched on, actually, we went through kind of the gamut with zero trust previously, but I kind of wanted to highlight a few things here in terms of critical ICS networks. So, the key things here, Jason also alluded to this, is really reducing that attack surface and leveraging protocol isolation. So I'm going to jump in and kind of show a visual of what we mean by this and why, utilizing legacy IT infrastructure like VPNs and jump servers can be problematic. But then also we have to meet the regulatory standards. So you have things like NERC CIP, IEC 62443, and NIST standards. Really there needs to be a purpose-built OT system that can meet all of these regulatory standards, right? So that also creates a challenge as well. And then we need to be able to provide a different way for users to access critical systems, but have multiple granular controls, so that we don't run into the water treatment plant or Colonial kind of situation. So really, we need things like time-based access controls, multi-factor authentication, virtual wait lobby, such as moderated asset access, and file transfer. So being able to approve a patch file, for instance, and do that at the plant level, and be able to not only have that file transfer enabled, but maybe only enable it for a particular asset, a particular system, and be able to make that unidirectional if needed. So if you want to ensure that only a patch file is coming in and there's no way that a file could leave the OT environment. And then, of course, bringing in full system logging, being able to monitor users and so forth, with actually easy output to traditional IT SIMs or log viewers. So these are some of this really needs to be the approach that is taken. It sounds like a lot of things, but there is, purpose-built OT tools for doing this today. So this is a little bit of a busy slide, but I'm going to spend a little bit of time on it because I think it's very important to understand kind of legacy IT, because what we've seen out in the environment is there seems to be kind of, hey, let's just do what we did in enterprise IT and we'll forklift that and drop it into the OT environment. Well, enterprise IT has kind of been built over, a decade or more, and there's a lot of different tools that are integrated, and it's really designed for the enterprise in terms of always on, 8 to 10 hours access, user access, hundreds or thousands of users, hundreds of applications. And so it may be complex, but it is that way because it's kind of grown up that way in IT. But being able to take all of these components and put it over in the OT when you might only have a dozen users and a dozen critical assets, it's really can become way too complex and costly, and there's just really a lack of resources. So when we look at the untrusted network, there's also the additional issue with bringing on OEMs or third parties, contractors, and so forth, because when you're using VPNs or even VDI or VPN, there's always an access methodology mismatch, right, between your third-party contractor and your organization. One has one type of VPN, another has a different, so that creates friction, right? So we want to kind of move away from this kind of friction-based approach, complex IT approach, to something that's really built for ICS, built for OT. And then on the cybersecurity aspect, even with this complexity, a lot of these tools allow the data communications protocol, such as RDP, to traverse through the firewalls, through the VPN tunnel, and back out to either the third party or the remote employee. This is problematic because if one of those machines has been, popped or, it's been compromised, now that's an attack vector that or a protocol that can be used to get into the OT network. And RDP is the #1 attack vector for ransomware. So this is so we have a combination here of expensive, complex, and insecure. So really the idea here is how do we make this much simpler and kind of collapse a lot of that IT infrastructure into a kind of built for OT environment that has some of these very specific needs that OT has, like time-based access control and virtual wait lobbies for access, and those additional plant level protections when users are accessing. So really, the idea is to build in sort of zero trust into the entire authentication and authorization mechanisms. So the first thing is, we want to make this more frictionless from the remote user standpoint. So being able to use a standard web browser without any client software or agents and things like that is the first part of this. So make it simple to connect from the client side, and then from the authentication, make that a mutual TLS connection and enforce multi-factor authentication, right? Either using OTP or WebAuthn. I think YubiKeys were mentioned before. That's a great way of doing that, and I think that's effective whether you have there is an IT to OT component or it's direct to OT. And then at sort of the interface you can think of this as sort of an authentication layer from the untrusted to the middle layer, and the example here I have is our critical system gateway. But then from there, you basically control the access and the usage of the protocol to the asset. So you define the connection, and then you broker that connection in that protocol, and you assign that to a user or group of users. So, but when the interface to the system in the OT environment comes back to the user, it's only a video stream, right? It's VDI. There's no data in transit going back to the user. It's essentially a video stream going back into the browser and then being able to operate that without worrying about the attack surface being extended out to the remote user, right? So only allowing one port out, what we call the untrusted network, and that being the encrypted HTTPS or 443. So this is really the more modern approach to solving the problem with providing a logical user access layer for OT, and this could be implemented with or without the cloud. It's just we've seen a lot of organizations that have the hub-spoke environment. They may use the cloud for maybe sending data analytics or things like that, but they don't want to use it for authentication and authorization to some of these critical systems assets. So when we talk about zero trust, and I'm going to kind of touch on a few things. I mean, zero trust is a very large term, but there's a few things here, I think, that differentiate kind of a built for ICS or OT access control system versus an IT, right? So one of the things is being able to assign an individual asset. Many places have VPN set up to provide network access, but the problem is if there's not additional policy controls on the network and things like that, you can pretty much move east-west within that network once you're authenticated. You want to have basically control to each particular asset that you're connecting to and be able to assign a user or group of users read-only or write privilege to that asset. So, in other words, the authentication and the access to assets are actually separated, and you provide that granular access, and then you decide whether the access to that asset whether you can enable file transfer for a patch file or to bring a file out of the OT network, and then you set the direction on that file on that asset. This sounds very granular, but this is really the approach that we believe that needs to be taken, right? So you can have it unidirectional to or from the host. And then you can also determine whether this asset should be moderated. So for instance, maybe they have the ability to multi-factor authenticate to the network. They have the access permission to a particular asset, but a visual or audio alarm goes off in the plant itself, and there has to be a plant manager that clicks and enables that access, and that's really kind of through moderated or virtual wait lobby to allow that control. And then, with OEMs and third parties, a lot of times you want to schedule around outages, and so you want to have, or you want to know exactly what time window, particular OEM may be coming into the system, so you can set up, time-based access control. So you can say every Friday, we want this particular OEM access for 4 hours every Friday, for instance. So. And then this was touched on, obviously, on the forensic side for cyber access forensics. But really, going beyond sort of, the access logs that are ported out to the SIEM and correlated and so forth, and being able to actually see the mouse clicks, the user keyboard input, and be able to create that as a movie file, if there is a particular issue or a threat's been detected, or there's a remediation that's in place, an incident you're going through, having that additional forensic detail of being able to see the user access to a particular site that may have been compromised is hugely important, right? Because then you can kind of see what was going on during that time and so forth. So yeah, so some of the use cases actually is kind of harks back to the very beginning. We talked about solar arrays and wind farms, but there are a lot of use cases that are very specific for industrial control systems or OT. You know, remote system patching can drive the implementation of remote operations for, you know, an HMI, for instance, or something that's controlling a solar array. The example here is, you know, it's an OT-only network. It's not going through the cloud or IT infrastructure. This is a large medical center out west with a solar array that's you know, using kind of an OT remote operations control platform. Mobile operations, so being flexible, not only does this be for remote operations, but if there's an iPad or a laptop and there needs to be maintenance checks or calibrations done around the systems, but you still need to be able to see the control room screen, this can unlock somebody from the control room and be able to do things around a plant while still being able to see the control room screen. We actually have a customer that they have a peaker plant and they're under an SLA where they could be fined if they don't turn on the turbine if they get an alarm, and they actually have an iPad. If they have to go around and do checks, that they can literally start up the turbine from their iPad as they're walking around the plant doing maintenance checks. So, you know, there's a lot of operational efficiencies, you know, beyond sort of the cybersecurity aspects of this as well. You know, being able to do more with less is really what it comes down to. Obviously, labor shortages are a big thing here, and you know, being able to do things like unmanned power plants, being able to bring back control room screens from one power plant to another and be able to operate without anybody in that control room. You know, obviously, labor savings there. Being able to bring kind of remote OT commissioning, so setting up new systems where there is no network and maybe hooking up a cellular modem and then being able to provide that zero trust to the systems there on site without really anything but power, right, and a cellular connection. So these are just some of the use cases. I think it's important to kind of understand in context of, you know, what problems are being solved. So I just wanted to kind of go over a few of these. But thanks very much, everybody, for joining. I'm going to hand it off now to Terry to take it from here.
Bill, thanks very much. You and Jason have set some great parameters for the Q&A. Before we go there, I would like to direct our listeners' attention to the webinar survey available at the bottom of the presentation window. Again, thanks in advance for filling out this feedback form. Now on to the question and answer part of the event. As a reminder, you can participate in the Q&A by typing your question into that text box located to the right of the presentation window. You can also click on the Q&A icon at the bottom of the screen. If we can't get to your questions that are submitted during the session today, we will share them with our speakers who can reply to you offline. So let's start here. Bill, a question for you. How does protocol isolation protect against ransomware? It's obviously effective against more conventional types of software. What's the perspective there?
Yeah, so I think, you know, really the way that folks get into networks, usually, you know, it's a multi-stage attack. You know, the user maybe is spearphished, you know, through email. There's a dropper malware that goes down. It establishes, you know, command and control, maybe keyloggers and things like that. And so, you know, if a remote user's device has been compromised and they've gotten through and basically been able to grab the credentials to authenticate, you know, now they have a way of, you know, seeing the information, seeing the protocol. They can now, you know, utilize that protocol right from that remote user's device to go in and, you know, start looking for systems or you know, maybe even connecting directly to a system. So if you have a a situation where the protocol doesn't leave the OT network. The protocol stays isolated to the OT network. You're essentially reducing that attack surface. So, combined with multi-factor authentication on the remote user's device, it becomes extremely difficult, right, to be able to do anything. And even if you were able to, so let's say, compromise, an OTP, SMS text for multi-factor authentication somehow, and you're on that device, if you don't have, if you don't have the protocol, if there's no protocol to use, and it's really just, pixels, then you're kind of stuck there, right? So that's kind of the key part of this is you really need to have some sort of data communication protocol to utilize to get into the network.
Thanks for that. Another interesting question. How do you provide third-party authentication to OT assets without cloud or IT infrastructure? Is that even possible?
Yeah, it's possible. So I alluded to kind of in the last use case, but it's also been set up with a few of our other networks where they either have a kind of way out in the middle of nowhere. You can think of it as sort of an oil drilling site or a solar array or things like that. Is to have a cellular modem. We've also talked in the maritime industry about using SATCOM, so to be able to have an OEM be able to access a particular system, on a ship, for instance. So, I mean, these are things that if you have the communications, you can go directly to the OT network. You don't necessarily have to authenticate through, federated identity management platforms or SAML 2.0. But the key is the flexibility. So, the idea is if the infrastructure is not designed to use the cloud for authentication, either it's hub spoke or you want to have direct access to OT equipment, being able to do that, but also be able to leverage kind of modern multi-factor authentication like SAML 2.0 in order to federate and then drop down from there into the OT network, right? So, thanks
for that. Another question about really, I guess, security, but also what I'll just call confidentiality. The question asks, I have several OEMs that remotely access their systems. How do you ensure that OEM A can only see their systems and not those of OEM B?
Yeah, so this really comes down to, setting up the authentication and assigning the assets, and this is also kind of dovetails into the whole zero trust architecture, right? So the idea of granular access controls to each individual OEM asset and assigning the control to that asset, the access control to that asset, to the group of users with that OEM or an individual user of the OEM. And so when they authenticate and they bring up what systems are on the network, the only ones that they're going to see are the ones that the systems that they've been assigned as in their connection profile, right? So in terms of, providing that authentication to the network and then, okay, we're going to set up a, policy to have you connect, but, if they're hacker type, they could probably still port or host scan the network segment they're on and find other systems, putting in methodologies that don't allow that kind of access is very important.
So there's a more of a statement than a question from our audience about how IT also needs to hold the line for security when OT wants more devices connected to gather data for things like smart digital factory initiatives, for example. I think what the listener is alluding to is IT and OT have historically been separate functions within organizations. Internet of Things is really encouraging / forcing the integration of these two kinds of systems. This doesn't feel like a technology issue so much as maybe a political one. Bill and Jason, I'd love to hear from you both about to what degree IT and OT need to manage, I guess, control issues like this that don't feel like technology issues.
Jason, you wanna? I can chime in if you want to start.
Yeah, sorry. I was going to say this is a really great point, and I think it has to do with some of the way I tried to articulate this. So in my slides, I had talked about how IT is coming to the OT practitioner saying we need a cloud connector, we need Active Directory, we know all of these things, and OT is taking a step back and saying that's adding risk. But to Chris's point, the opposite is also true. It sort of has to be this bi-directional communication. So the OT, they can't just be going to IT every day and saying, we need more devices, we need this and that connected to, other, as he says here, digital factories and other areas. So the point is that this communication between the IT and the OT team definitely goes back, between the two, bi-directional. So there needs to be a good understanding of each other's kind of risk appetite, and that way you're not sort of explaining, what are the risks to one group. It should sort of be understood. So I think that has to do with my example. Like I said before, I only talked about the one way, IT coming to OT saying we want to add Active Directory and cloud connectors, but to Chris's point, it's very much true the other way. OT can't go ask for more devices every day.
Yeah, I think there is kind of a political issue and there is kind of a cultural issue with the OT and IT, but a lot of these things with gathering data, what we've seen out there in the field is, some of these manufacturers have a lot of control over the factory, if it's a manufacturer site, and they've kind of handed off the keys to the kingdom in a lot of cases, and so that creates a lot of friction when you're trying to administer that, and then it can create obviously friction with cybersecurity analysts, professionals, and so forth up to the CISO level. So, yeah, I think it's just we got to make sure all the stakeholders are together on it, in IT and OT, before anything goes in that connects to anything. So.
Fair enough. We are bumping up against the time. And I think we'll need to close out the Q&A. I think we have time for just one more question, though. A listener asks if our speakers can name some of the tools used to protect industrial control systems that were mentioned.
Yeah, so we provide kind of an integrated remote mobile operations zero trust platform for user access at Xona. There are a number, when you get into cybersecurity and vulnerability detection and so forth, there are a number of companies that focus more on sort of the asset discovery and vulnerability management and threat detection, such as Nozomi Networks and Dragos, and there's a number of others, but Tenable, ForceCal, there's quite a few, right? So there are purpose-built tools out there for doing that, and they can work in concert with what we do in terms of providing zero trust user access control. Okay, that's.
Sorry about that. That's unfortunately all the time we have for questions today. Thank you, Bill Moore of Xona, and independent researcher Jason Clark. Dark Reading appreciates your time and expertise on today's topic. Special thanks to our sponsor, Xona, as well as to everyone in the audience. We certainly appreciate your attention and participation. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been able to listen to the event. This webinar is copyright by Informa. The presentation materials are owned by or copyrighted by Dark Reading and Xona, and the individual speakers are solely responsible for their content and opinions. On behalf of our guests, Xona, I'm Terry Sweeney from Dark Reading. Thanks again for your time. Have a great day.